Okay, today we're starting a lesson called Absolute Values and Inequalities, and you are solving them. First of all, a few tips to get going. Answers from 2-5, that is our answers that we had from the last section that look like hockey goals or hockey sticks, will look the same as they did in 2-6. Okay? So when you get to the end of each problem, you'll see that composite inequality. One final reminder before we jump into the problems, remember that absolute value equations have two solutions. So that's why you're going to see arrows in each of my problems showing the two different problems that we need to solve in each case. All right, here we go. First problem. Solve and graph. 8.5 is less than or equal to t. So the first problem you write down is 8.5 is less than or equal to t. This problem is now solved. Notice the t is by itself, and so we're ready to graph that. I'm going to run over and to the other side and write my opposite equation, which, if you recall, we start with 8.5, leave it alone, leave the inequality alone, and write negative t, the opposite of t. So we want that to be positive t. The way we get that is you multiply by negative 1. So I take the 8.5 and we're going to multiply it by negative 1. So we have negative 8.5. Don't forget, the inequality symbol flips on us, and you get t. So now I take these two statements, and I'm going to put them together on a number line to show my solutions. Right now, we don't know if this is a hockey goal or hockey sticks, but if you've done your math correctly, you'll see clearly one of the two things show up. So I'm going to go to 8.5 as my boundary point, fill it in, and again, because my statement says greater than 8.5, we go to the right. Likewise with negative 8.5, it says all the things that are smaller than 8.5. So we go to the left. So here now are all my solutions from 8.5 and up to negative 8.5 below. And you can see this is an OR scenario. Okay? So don't forget to circle your answers when you're done. Here we have 8.5 and negative 8.5 as my boundaries. Example 2. A little bit more complex. Now we have an absolute value surrounding an x plus 3. So we write down the problem without the absolute value. Then I write it down again, this time taking the opposite of what I see. And we proceed to solve. Subtracting 3 from both sides. On the left, we're left with x is less than 8. That looks like it's cooked, ready to solve, ready to graph, that is. On my right side, this time I need to add 3 to those sides. So I get 11. But we have a negative x, so we have to change that to a positive x. And again, we do that by flipping both of the symbols on each of the sides. Remember also to change the inequality. Now comes for the number line. So I need 8 and negative 11. And I should probably put 0 down. This time, it's all the values that are smaller than 8 and all the values that are bigger than 11. So we can see this is a hockey goal. So this is an and statement. Important to get that word in there so that we just see what type of solutions we have. Our last and final example. Quite complex. A couple things to point out before we get going. There is an inequality sign here, and my variable is right there. Okay, and there's lots of different pieces here. There's a 3 and a -7. All right, So first of all, we're going to write it down without changing anything, except that we just drop the absolute value. I replace it with a set of parentheses because I need to multiply that 3 through. 3 times d gives me 3d. 3 times 1 is 3. Minus 7 is greater than or equal to negative 1. Remember from our multi-steps problems, you want to get rid of the parentheses first. Now I'm going to collect any terms that I see are alike. I see a 3 and a negative 7. Last time I checked, that's negative 4. And so now we need to cancel the negative 4. I do that by adding 4 to both sides. And that negative 1 turns into a 3. On the right side we have a 3d. Dividing by 3 both sides, we get d is greater than 1. Phew! That was a long problem. Got the variable by itself. Now we're going to go over and solve the opposite problem, which is 3. And then in parentheses, the absolute value. Remember, we take the opposite of the d, opposite of the 1. Don't change the 3 or the 7 because they aren't in the absolute value. And don't change the negative 1. And I'll proceed the same steps. So we're going to multiply by negative 3, positive 3, excuse me. We'll get a negative 3d and a negative 3. Minus the 7 is greater than or equal to negative 1. Parentheses are out of the way. And now we collect some like terms. And so we have a negative 3d plus a negative 10. Yeah, that's a negative 3 and a negative 7. Adding 10 to both sides to further get the d by itself, we get negative 3d is greater than 9. Finally, dividing by negative 3, we end up with d is greater than negative 3. And so I have my second solution. And we'll graph this on a number line. So exciting. Notes are done. Almost. There's 0, there's 1, there's negative 3. And again, we're saying all the values bigger than 1. So drawing a circle at 1, shading to the right. And then d is all the values greater than negative 3. Now, I purposely made a mistake here so you would see a situation where I made a clear error and I got the 2 hockey sticks going the same way. The second one is where we suspect the error happened, and you can see I forgot to flip my symbol when I divided by a negative. That shouldn't be d is greater than 3, it should be d is less than negative 3. So we come over here, flip that that graph around, and now you can see we have shaded everything to the right. Okay, now it looks like it's supposed to. We'll cross off the bad answer so I don't get it marked wrong. There's my right answer. And we can see this is an OR statement, by the way, because it's the 2 hockey sticks. Okay, good luck in your homework. Hope that works out.